Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I've already uploaded Module 1 to Module 4 topics in my channel. If you have missed out, please do watch. In this video, I am going to teach the Bode plots problems, how to construct Bode plots. Already we have discussed some three topics under the Bode plots. And now we will see how to draw these Bode plots using this theory. This is the easy trick how to draw the Bode plot. They are in terms of steps which you should follow while you are doing a Bode plot, when you are drawing a Bode plot. That is, find the rising slope or falling slope, find for the single turn S. That is, for example, if it is 1 by S, S inverse, n power minus 1 it is, means falling. If it is S square, it is plus 2. So it is rising. Then rewrite the given open loop function in time constant form. That is 1 plus st form you should write. Then replace S by what? J omega. Replace S by J omega. Then find the value of K. If it is not given, assume K as 1. If it is not given, we should assume K as 1. Find the corner frequencies and respective slope. We need to find the corner frequencies and respective slope. Find the initial slope and final slope. We should know the initial and final slope. Then find the magnitude for respective corner frequency. We need to find the magnitude for respective corner frequency. Okay, magnitude, and even we should draw the phase plot, magnitude plot and phase plot, and draw on the Bode plot, and from that even we can infer the gain margin and phase margin also. As we have studied the same topics in the previous videos. Then note, if it is one pole, then it is called minus 20 dB. Okay, if it is a pole, it is minus 20 dB by decade. If it is 1, 0, then it is 20 dB by decade. Okay, if it is a 0, 20 dB by decade, and if it is pole, minus 20 dB by decade. Then to find initial slope, how we will find initial slope is plus or minus n into 20 dB by decade. Number of poles or number of zeros into 20 dB by decade. The final slope, how we will get? Poles minus zeros into minus 20 dB by decade. If you do, you will get the final slope. Magnitude, as you know, the formula is 20 log K plus or minus n 20 log omega. Okay, 20 log K plus or minus n 20 log omega. We'll see the first question. Construct the Bode plot for the function g of s is equals to 80 by s into s plus 2 into s plus 20. Here, first we will find the rising or falling slope from the function. We get what? 1 by s is equals to s inverse, that is equals to n is equals to minus 1. That means what? It is falling slope. Right? Why? Because you have a 1 by s. It is a falling slope. Slope means what? It is what? It is minus 20 dB by decade. Why? Because it is a pole. One pole at the origin. Means what it means? That it is minus 20 dB by decade. Then g of s into h of s. Then you will get what? Here the equation what is given is 80 by s into s plus 2 into s plus 20. What we should do? We need to write in the form of time constant, that is 1 plus st. In this form we should write. To get that, what we will do is 80 by s into, if you take 2 common, then what you will get? 1 plus s by 2 you can write, no? Then 20 common, you will get 1 plus s by 20. So if you cancel this with this, you are left with 2. So 2 by s into the same equation we got here after simplification, that is 2 by s into 1 plus 0.5. Nothing but 1 by 2 is 0.5. 1 by 20 is 0.05. Yes. 1 plus 0.05. Yes. 1 plus 0.05. Yes. Just write here. Yes. I missed it out. Yes, my 0.05 s. Now what we should do? We should replace s by j omega. Simple. 2 by j omega into 1 plus 0.5 j omega into 1 plus 0.05 j omega. So k value, how we have what? K value here. This is the k value. Here the as k value is given. So you can write as 2. 2 is the k value. Okay. Then, now in step 5 what you should do? We need to take the factors or the terms and write the corner frequencies and its slope and results in slope we should write. So, first factor is what? 1 by j omega. First factor we have is what? 1 by j omega. See, what we have is 2 by, I'll write here once, 2 by j omega into 1 plus 0.5 j omega and into 1 plus 0.05 j omega. 0.05 j omega. So it is written as means 1. Here upper side it is taken as 1. You will not consider that 2. It is k value. K is 2. So you will not consider that. Here for taking factors, we will just consider the into 1. 2 into 1. This is 1 by j omega. 1 factor. So same way 1 by 1 plus 0.5 j omega. And next is 1 by 1 plus 0.05 j omega. You have written the factors. After writing the factors, what you will do? You will write the corner frequency. For this corner frequency, it is 0 anyway. So 0. The slope will be what? Minus 20 dB by decade. As it is 1 0 present at the, it is a 0. Pole. It is a pole which is in the denominator. As one pole is present at the origin, it is minus 20 dB and resultant will be what? No resultant slope from the previous, so it is the initial slope it is. Then what you have is 1 by 1 plus 0.5 j omega. For this corner frequency will be what? WC1, that is first corner frequency. 1 by 0.5 if you do, that is nothing but 2 radian per second. It's the first corner frequency. Then its slope will be what? Minus 20 dB by decade. As it is what? The pole. As it is pole, it is minus 20 dB. And previously what you have? Another minus 20. So resultant will be what? This previous 120 and this 20. That is minus 40 dB by decade. Then third factor, 1 by 1 plus 0.05 j omega. Corner frequency will be what? You should take this 1 by 0.05. Means you will get 20 radian per second. 20 radian per second. And again it is a pole. So you will take minus 20 dB by decade. And if you add with the previous resultant slope, you will get minus 40 by 20, minus 20, you will get total resultant slope as minus 60. After doing this, till here it is done now. After doing this, you need to find what? Initial slope and final slope. Initial slope already you got to know, that is minus 20 dB by decade, or you can, or else you can even verify with the formula, that is plus or minus n into 20 dB by decade. N is what? Minus 1. N is what? Minus 1, and 20 dB by decade, that is minus 20 dB by decade. Okay. Then final slope. N, how we find out? 1 by s. At the origin it is minus 1. No? So minus n is equals to minus 1. So minus 20 dB by decade. Or already initially it is known. If you write this or not write, it is not required, but you should write like initial slope is minus 20. Final slope will be what? Minus 60. What we got? That is minus 60. Using formula, how you can find? Pole is how many poles you have? 3 poles you have. Zeros you have 0. 3 minus 0, 3 into the what the for the poles what it is? Minus 20 dB by decade. So that is nothing but minus 60 dB by decade is the final slope. After this we will write what? Magnitude plot. This is a magnitude plot and this is a phase plot. So for magnitude plot, what you will do is that, see, we have the factors as what? First one is 2, then you have this is 2, then 20. But initially we should every time consider the what? The frequency as 0.1. In the Bode plot, when we are drawing on a semi-log graph, when we are drawing on a semi-log graph. The graph what we use for this is a semi-log graph. While we are drawing, we should take first initial point as 0.1. It is for compulsory. Then what you have here? 2. So take 2. Then you have what? 20. So then take 20 as third corner frequency, and last you can take as 100. How it is written is 0.1, 1, 10, 100. Like that you are going to give. As here it is 0.1, 2, 20 and 100 you will take. Then what you should do, the formula you know that for the magnitude it is 20 log k plus or minus n 20 log omega. If you substitute omega in this, what you will get? You know the value of k. As here you know the value of k, that is 2, and n is minus 1. You know those values. What you will do? 20 log k value is 2. Then minus n 1 minus 1. 20 log omega plus 0.1. Omega in place of omega 0.1. You will get what? 26 dB by decade. In the same way, if you put 20 log 2 minus 1, 20 log in the omega place 2, you will get 0 dB. Same way for 20 and 100, you will get minus 20 and minus 34 dB by decade. This need to be plotted on the magnitude plot of the Bode plot. Then phase plots we should find. For phase plots, what you have the formula? That is minus tan inverse of omega by omega c. Omega by omega c is nothing but what? 1 plus st, no? 1 plus st, 1 plus omega by omega c. T is nothing but omega by omega c. Omega by omega c value is, first frequency is 2. So you will got what? The terms 1 by 1 plus 0.5 j omega. So in the place of omega c, what is the value? 0.5. 0.5 is the omega value. So what is the formula? I'll write here. See, minus tan inverse of omega. This is the angle you can get. Phase formula is this. So easily you can find, that is 1 by j omega. At the origin, every time the phase will be minus 90 only. Right? Omega. If you put the omega value also, tan inverse omega. Tan inverse at the origin, you will be having minus 90 degree as phase. That you need to remember. Then what you have is terms 1 by 1 plus 0.5 omega. Then for the phase, you will get minus tan inverse of 0.5. Minus tan inverse of 0.5. Then 1 by 1 plus 0.505 omega. For this value, what you will have? What you will have as the phase is minus tan inverse of 0.05. This is the omega c. So you will get 0.05 as the formula. Then after adding these all, the total phase formula will be what? Minus 90 minus tan inverse 0.5 omega minus tan inverse 0.05 omega. Right? Omega by omega c. Formula is what? Minus tan inverse omega by omega c. Minus tan inverse omega by omega c. In the place of omega c, you have put the 0.5, 0.05. See, omega by omega c. Right. Here 0.05 you have put in the place of what? This 1 by omega c. 1 by omega c. 1 by omega c value is what? 1 by 2. Right. So omega c value is 2. So 1 by 2 means again you will get what? 0.5 only. So what you will do here, if you put the value there, then you will get, you are left with what? Tan inverse of 0.5 omega. So like that you will write the formula. Then minus tan inverse 0.05 omega. Okay. After writing this, you need to find the phase plots for different values of the omega. For that compulsory 0.1 will be there. For, as I told, it should be there. Then this second frequency is also required. Second corner frequency and 20 also required. In between you should take for 1, 10, 50 and 100 for the smooth curve. So that you will get exact points on the graph. When you do this, minus 90 minus tan inverse 0.5 in omega place 0.1 and minus tan inverse 0.05 in the omega place again 0.1. If you calculate this in the calci, you will get these values. After getting these values, we are left with what? Just pointing this on the graph. Just pointing this on the graph we are left with. See, now we got the points now. Now we should just put the values on the graph. First we will understand this semi-log graph. This graph is called semi-log graph, used it for Bode plot graphs. Bode plot, for plotting the Bode plot. See, here for magnitude, this is for magnitude and this is for phase angle representation we'll use. Okay. For here, this is axis of y-axis, this as x-axis, here this y and this x-axis. Keep this in mind. And after this, what we should do? We need to write the values. Here if you take this as 0 dB, consider this 20, 40, 60 and 80. Okay. Then you have minus 20, minus 40, minus 60, minus 80. How much values you got? Till there you need to consider. After considering that, what you will have here, how we should draw is, see, this is 1 point here. Okay. This is 1 point. This is 1 point. And the points how you write is 0.1, 1, 10, 100, 1000. Like this only you should write. Point. For every graph you should mention this. 0.1, 1, 10, 100, 1000. For every end of the line, the thick line is there, no there. After writing, in between what you have, you should 0.1, 1. You got the values. Okay. After writing that, you need to mention in between values. What values you want in between? 0.1, 1, 2 you want. 2 will be here. 2 will be here. Then you want 20. 20. 2. Then you want 10 also. No, 10. 10 will be here. 10 will be here. Near to 20. 10 will be near to 20. Then 10 and 20. After 20 you want 50. 150. In between you have 50. Okay. Then you are left with 100 and 1000. Anyway you don't want 1000. After drawing till here, what we should do? These two you will get afterwards. But then this 2 anyway you are calculating. This 7 we will get later. Still first we should mention only this 0.1. First we should mention 0.1, 1, 10 and 100. Then in between values, what you want? 20 here near to 10 and 50 between, and that's it. These values you should mention, and 2 is between the near the 1. You will mention till here. After mentioning till here, what we should do? We should start plotting the graph. First we will see for magnitude plot. What we have, that is for 0.1 you are getting 26 dB, that as we have calculated. For 0.1 where you have, here you have 0.1 minus 26 dB. Somewhere here you will get minus 26. 0.1 minus 26. So mark it here. Okay. Then for 2 you will get 0 dB. So it is mentioned 0 at 0 dB. Okay. Then for 20 you will get minus 20 dB. What you got is minus 20. So minus 20 dB is somewhat here. It is mentioned. Okay. Then minus 34 dB. For 100. For 100 you will get minus 34, somewhat you will get here. Approximate values you can put. Why? Because see, 20 in between 30 you will get. Somewhere after 30 if you put, that is nothing but 34. Once you got all these points, what you will do? You will just draw a line on this. Right? See, this is minus 20 dB and again minus 20 dB. Accordingly you mention the slopes also. Lastly you will get minus 60 dB and here it is 40 dB. So you are done with what? The graph of the magnitude plot. Now we are left with what? Phase plot. For phase plot, what we should do? Here you should mention the degrees. That is from minus 180. In the in the theory also we studied. After the minus 180 degree it should be before the minus 180 degree. So minus 180 degree is the base point for the phase margin. So for the gain or the magnitude plot, 0. Okay. From here for the degree we will write from minus 180. So minus 180 in the between, same like 0. Then 60, 90 you will take. See, if it is 180, you can consider 30 difference. 150, 120, 90, 60. 18 plus 30, 210, 240, 270, 300. 30 difference I have took here. After taking till here, we should again start pointing the things. See, for the phase plot, for point 1, what value you got? Minus 93.14. So minus 93, 90 is here. Somewhere here you will get, see, minus 93.14 here. Then for one what you get? Minus 119.14. See, minus 119 is almost here. See, it is mentioned minus 119. Then for 2, minus 140. For 2, minus 140. Somewhere in here. Somewhere here you will get minus 140. Okay. Then for 10 you will get minus 195. Minus 195. Somewhere here you will get. See, for then 20, 219.28 here. Then for 50, 245. 245 means somewhere near only here. Okay. For 100 it is minus 257.257, somewhere here you'll get. After getting, you will draw a line passing to these points. So this is which plot? It is phase plot. Phase plot is done. Now the whole Bode plot is done. Now from this, what you can find is the gain margin and the phase margin. If you see here, the gain margin found here is, so here you can see the gain margin calculated, that is the point where the phase crossover will go beyond the minus 180. So this will be the phase crossover frequency. This is the phase crossover frequency. At this place only gain margin is found. This is the gain margin. 0 minus something, here value, that is minus plus 20 dB decade. Then if you want the gain crossover frequency after 0 at the point of origin, what it is? No, that is the gain crossover. That is what? The gain crossover. That is what? Here it is connecting to what? 2. So that will be gain crossover frequency. And at this point, what you can find? Phase margin from here to the point which is touching here. Okay, that will be what? The phase margin. That is, you can minus the 140.17 minus 140.17 minus of minus 180 if you do. Why? Because it should crossing minus 180. This is the point. Minus of minus 180, you will get 39.29 as phase margin. 39 degrees is the phase margin. Like this, you can even calculate phase margin and gain margin on the graph. So I clearly explained this graph so that the other examples can be done fast. So this is the first example, so I am going slow. From the next sum, I will go little bit fast. Second question, if you see here, g of s transfer function is given in this way. For unity feedback system, draw the Bode plot. First you will find what? The falling slope, that is 1 by s you have, that is s inverse. N is equals to minus 1, you will get falling slope, that is minus 20 dB by decade. So rewrite the given equation in the form of 1 plus st. How you will write? You will take common of 2 here, 50 here, 200 here. You will be left with 0.4. So the k value will become 0.4. And you will write the s terms in terms of j omega. You will get the equation in this way. After writing in the terms of j omega, what you will do? You will find the corner frequencies. For finding corner frequencies, what you will take? You will take the factors. First factor is 1 by j omega. And second factor is 1 by 1 plus 0.5 j omega, and third factor is 1 by 1 plus 0.02 j omega, and fourth factor is 1 by 1 plus 0.05 j omega. For finding the corner frequency, there is no corner frequency for this, so it will be slope anyway. It is a pole found, so it will be minus 20 dB itself. No resultant slope for the initial one. And the second one, corner frequency will be 1 by 0.5, will be 2 radians per second, and the slope is minus 20 dB by decade as it is a pole. So after that, if you add these two poles, you will get the resultant slope. That is the previous one and the present one, minus 40. Then for the third factor, the corner frequency is 1 by 0.02, you will get 50 radians per second. You will get minus 20 dB as 20 dB as decade. Why? Because as it is a pole which is present in the denominator, for the pole the slope will be minus 20 dB by decade. Okay, then resultant slope will be what? 20 plus 20 plus 20, 60 dB. Okay, then for the fourth factor, same way, corner frequency 1 by 0.0005, we will get 20 radians per second, 20 radians per second, and the slope will be minus 20 dB by decade as it is a pole. So resultant slope will be what? Minus 80 dB by decade. So initial slope is minus 20 as you got initially. Final slope is what? Minus 80 dB by decade. Or else you can even find using the formula. You will get the same. After that, what you can do? You will get the corner frequencies. From that you can write the magnitude plot values. So initially we should take for sure 0.1 initial value, and the second corner frequency you have 2, and you have 50 as one more corner frequency, and 20 as one more corner frequency. 50 and 20, I think it is 200. 1 divided by 0.05. 1 divided by 0.05. You will get 200. It's my mistake. It is 200 radians per second. It is 200 radians per second. 200 radians per second. So next is corner frequency is 200 and 1000. So you got some different values. For these values 0.1, 2, 50, 200 and 1000, what you have the formula 20 log k plus or minus n log w. Here you have the k value as what? 0.4, k value as 0.4 and n value as minus 1, initially what you calculated. If you put the k value and omega value in this, k value, n value and omega value as 0.1 and find using the calc, you will get different magnitude plots with frequency, that is omega. So you can plot on the graph. Then even you want the phase plots also, right? For phase plots also you will take the all terms, for all terms, then the formula will be minus tan inverse omega by omega c. Okay, as the omega c value you have is 0.5, that is 1 by 0.5. Omega here value is in the form of omega c itself. So 1 by 2 actually. Omega c value is what? 1 divided by 2. So 0.5 you will get. So tan inverse 0.5 omega, and you will get tan inverse of 0.02 omega minus tan inverse of 0.05 omega you will get. After finding this, you will add them all. You will get in this way formula for different values of omega. The compulsory values are 0.1 and you have 2, you want for 2, then you want for 50, then you want for 200, right? So these values are compulsory for corner frequency. In between you can take any of the values like 20, 100, 500. So you will get a good slope, nice slope to draw. Okay, you will just put the omega value in this equation. For the equation, different omega values, you will get different values. After that, you will same in the last graph, you will take magnitude plot here and the phase plot here in this way and magnitude plot in this way. Then after finding for magnitude plot, you will take 0 dB as a reference, here minus 180 as the reference. Okay, and after that you will mention the points based on the different values you got. Like this, you will draw a line for the magnitude plot, and this is what? The phase plot. Same like previous one only you will do. And you can find even what? The phase crossover frequency. This will be the phase crossover frequency, but it is crossing minus 180. So it is phase crossover frequency. At this point you can find what? The gain margin. Gain margin you can find at this point. Okay. This is the gain margin. You can find at this point you got some value, and for the phase margin what you should do, which crosses the 0 dB, that will be what? Gain crossover frequency. At that point what you can find? The phase margin you can find. The phase margin will be this. So this value minus of minus 180 if you do, you will get the phase margin. Same like the previous sum. You just take the reference of previous sum. The same way the graph is drawn. In the third question, construct the Bode plot for the given transfer function. See, it is little bit different from the previous one. Drawing the graph is same, but if the questions are in this different form, you should start working out on different sums so that you can easily draw the Bode plot. See, first rising and falling slope you will write. That is, again you have 1 by s, so 1 by s power minus s inverse, that is equals to n is equals to minus 1. Falling slope, for example, if there is no s value here, if it is not there, then what you should do? There is no s value, no, s power 0 it is, so the n value will be 0 only. Okay, just understand in that way. So 1 by s is s inverse, so n will become minus 1. So falling slope it is, so minus 20 dB by decade. Falling slope means minus 20 dB by decade. If it is rising slope, it is plus 20 dB by decade. As it is falling slope, it is minus 20 dB by decade. For example, here it is s square. For example, you think. Then 1 by s square. So n will be minus 2. Like that you should remember. You should do. Then k value, you will get k value you can find directly like this, or you can, while doing also, you'll get finally the k value. Okay, first you can find the k value. How? You're left, we have numbers like 300 into 4. 4 you will take common, so 10 again you will take common, 20 you will take again common in the numerator. So you will get 300 into 4 by 10 into 20. Okay, what you will get? 6 as the k value. After getting the k value, okay, you can find the 20 log, okay, you will get a is as 15.56. Then rewrite the given function, that is 1 plus st format. You will write, you will take same way like here how you did, no, for finding k. You will take 300, it is always, it is anyway out, 4 you will take common, so you can write it as 1 plus 0.5 s plus 0.25 s square. So as you are taking 4 common, you will divide for these 2s by 4 and s square by 4. So it is becoming like this. So here you will take 10 and 20 common, it will become 200. 10 and 20 common if you take, you will get 1 plus 0.1 s into 1 plus 0.05 s. Then you will get the value. Here also if you see, the k value are getting 6 only. Like this also you can do, or directly you can find initially only k value like this. After finding, you will replace s by j omega. You will get this equation. After getting the equation, you will be having factors. You have totally how many factors? 3 factors. That is 1 by j omega, 1 by 1 plus 0.1 j omega, 1 by 1 plus 0.05 j omega, and one more which is on the numerator, which are zeros. These are zeros. So it is 1 plus 0.5 j omega plus 0.25 j omega whole square. This is one more factor. First we will see the poles. For poles it will be every time minus 20 only. For zeros it is what? Plus 20 dB you will get. Plus 20. Okay. As it is what? Second order pole. See, here it is s square. If it is second order system, then you will get plus 40 dB. If it is a first order system, then you will get plus 20 dB. Okay, keep that also in mind. Here why you got 40 dB, you don't get confused. Anyway, I'll explain once again one after the one table. See, these 3 are poles. For poles, what is the corner frequency? Here it is 0, minus 20 dB. It is same for the previous also. You will get the corner frequency as 10. Here corner frequency as 20. So the slope will be minus 20 by, because it is what? Pole. For pole it is minus 20 dB only slope. Resultant is minus 20 plus minus 20. Minus 20 minus 20 minus 40. These 3 if you add, you will get minus 60. And the main thing is, final one is zeros, which are on the numerator. These are called zeros. zeros and poles, no, zeros. For zeros, if you see, it is in the order of 2. Order of 2, for order of 2, you will get the slope as plus 40. If it is order of 1, just s is present, then it is not in the form of s square, it is in the form of s power n, or else j, in the place of s we have put j omega, no, j omega square or j omega whole power 1 only it is there. Then you will take j omega whole power 1 means just plus 20, as it is j omega whole power square, that is whole power square means second order system, so plus 40 dB you will take. The corner frequency will be what? Omega psi is equals to omega n square, that is equals to what? You will get 4, and omega n is what? 2. Okay, 1 by 0.5 you can do, or 1 by 0.025 you will get 4 and 2. Here omega n square. So like this you will get the omega n value. After getting the value, resultant slope will be what? All you got is what? Minus 60. Minus 60 plus 40. What you will get? Minus 20 dB decade. Okay, like this you need to find if the question is like this. Initial slope is minus 20 and final slope is minus 20. Okay, I hope you understood. Even using formula also you are getting the same. Then after finding the corner frequencies, initial corner frequency you should consider 0.1. Then next you have 2. Next here you are considering what? 10. You have corner frequency 10 and 20, and you have corner frequency 2. So 0.1, 2, 10, 20, and one more you take as 100. So you will get a smooth curve. Okay. Once you are done, what you should do? You should take the formula 20 log k plus or minus n into 20 log omega. So n here k value is what? 6, and n value is what? Minus 1. Just substitute k value, n value and omega value in this for all the values. So you will get what? Different values that you can draw on the graph. After getting this, what you should do? Phase plot. For the phase plot, what you should take? You should take all the factors again. After taking all the factors, minus tan inverse of omega, that is anyway you will get this as minus 90 as it is in the origin, and minus tan inverse 0.1 is what? J omega. Minus tan inverse of 0.05 j omega is what? Okay, then minus tan inverse, as it is pole, till now we have poles, you are doing like this. If it is zeros in this way, then what you should do? For zeros the formula is tan inverse of, okay, omega by omega c, that is 0.5 omega by 1 minus 0.25 omega square. 0.25 omega square means, see, I'll clearly explain how the zero is calculated, so it should not be confusing for you. See, tan inverse, first not tan inverse, first we will calculate that. See, it is in the form of 1 plus 0.5 j omega plus 0.25 j omega square. If you see, j omega whole square means what? J square is nothing but minus 1. So minus 1 into omega square. So how you can write? 1 minus 0.25 omega square, as it is j omega whole square, you can write 1 minus 0.25 omega square plus 0.5 j omega. So it is in the form of a plus jb. Whenever it is in the form of complex conjugate, it is a plus jb. What you can do is tan inverse of, plus tan inverse, here it is, okay, plus tan inverse of the omega value that is present with the j, that is what? 0.5 omega by 0.5 j omega by what you are left with? A. This way, A. You should write A what? 1 minus 0.25 omega square. You need to remember in this way. After writing, you will add these all things. You will just find the formula, and what you will do? You will find the values for different omega values, whichever you want, whichever you got as a corner frequency, and if you want any extra also you can take, so that the curve will be smooth. For one value you will get, and you will get final phase angles. Okay. After that you will get the graph in this way. If you draw on the semi-log graph, see, this is one graph and this is one more graph. Okay, like this. Here again you can find the, from this you can find the phase margin and the what? Gain margin. I didn't find out here. If you want, you can find. For example, if this is 180 dB, this is 180, no, 180 degree at this point, means at this point, it is coming here. So this will be what? Phase margin. At this point you can find the gain margin. At this point you can find the gain margin. Okay. In the same way, for the gain crossover frequency, what you will do, where the 0 dB is, if you see here, there is no value crossing the 0 dB. Means what? It is the see, there is no value crossing the 0 dB. So there is no gain crossover frequency over here. Okay. Then in the same way, fourth question, there is a question given like this. You need to, same way, S is equal, I'm giving you this as the homework. So I'll just explain fastly. You can just do by yourself. Same way you'll find the rising or falling. Afterwards you'll find the K value. As there is no K value, you'll assume it K as 1, and you will convert S into J omega, and you'll write the corner frequencies and find the resultant slope, then initial slope, final slope. Then for the different crossover frequencies, you will find the magnitude plot for different values. Then phase plot you will write. Then you will get a formula from this, that is minus tan inverse 0.01 omega, 0.25 omega, 0.1 omega. Then after getting the values, what you will do, you can find the K value now. That is how 20 log K is equals to what? 8 dB. Log K is what? 8 dB by 20 dB. So log K is what? 0.4 dB. K equals to, you'll get 2.51 as the K value. Like this you can find the K value also. Okay. So this is the graph drawn for the question what we have done. I'm just showing so that it will be useful. You can do as a homework and you can verify with this. So I am showing this. Okay. If you have any doubt, you can put in the comment box. So we are done with successfully the third chapter of the module 5. So in the next video, I'll start the fourth module. We have been done with the problems also with the Bode plots. Okay. Thank you from Sri Sai Tech Edu YouTube channel. Read, Lead, Success. Keep reading.